Hi, my name is Justin, and I'm one of the customer success engineers here at Xage Security. Today, I'll be demonstrating the use of the Xage Dynamic Data Security product. This demo is intended for developers only. The Xage Dynamic Data Security product enables the digital transformation of today's OT networks. This product allows for secure data sharing and provides access to trustable data, allowing for confident data-driven decisions to be made. We offer tamper-proofing of the data and access to this data wherever authorized. This enables multi-location, multi-party, and edge-to-cloud data sharing. When data is ingested by the Dynamic Data Security offering, it is then automatically encrypted and relayed across the Xage fabric. With the Dynamic Data Security product, our customers can confidently perform data-driven operations and are enabled to share and cooperate with multiple parties using this data. As we can see in the diagram, we have two process data sources that are leveraging the Xage Fabric APIs at the edge to write data to the Xage Security Fabric. The data is then replicated to the private cloud or data center of the customer's choosing. Data retrieval can then be performed either at the data center or via the cloud by leveraging the Xage Fabric Read APIs. Some developmental work on your end is required to enable the data sources to write to the Xage Fabric APIs, and additionally at the other end where this data will then be read and consumed by users or applications. Next, I'll go over how Dynamic Data Security APIs are leveraged to write data mimicking a data source. And then, I'll go over reading the data using a specific user that has been provisioned access to the data that was written. I will then show how data write protection is enabled so the data can be blocked from being written on demand. And then, we will go over how an individual user will experience not being able to read data from a data source they have not been provisioned access to. In order to perform these tasks, we'll first need to look at the configuration of the user and the data sources within the Xage Manager UI. Here we see that the user Mickey has been created. If we locate his profile settings, we see that there is an authorization access token. In the Python scripts we'll be showing you, we call the API login endpoint of the Xage Manager as a shortcut for supplying the access tokens required to call the device read API. We'll explain more about that later. Next, we'll look at the configuration of data sources within our device inventory. Here we see that data source 1 is allowed write access to the Xage Fabric APIs. Data source 2, however, has not been allowed access to the data write APIs. Additionally, we've configured a read policy for the user Mickey to read from the data source 1, but not from data source 2. Here we see our data write script. The script is used to show how a data source can write data to the Xage Fabric API at the edge. We have configured the certificates required for the API call directly within our script. We then identify the host, port, and API endpoint we'll be calling. Next, we issue the call to write to the API endpoint, and we see at the bottom that we're ingesting a simple string of data with the text, just any random data from device 1. This is to show that we're agnostic of the data being written to the API, and we simply ingest the data and replicate it from the edge to the center. In order to demonstrate this, we'll call our data write script and show a successful response indicating that the data was successfully written to the Xage Fabric API from the data source 1. Here we see a successful 200 reply indicating that the data was successfully written to the API. Next, let's take a look at our read API script. Here, we're leveraging our Python script to call the login API endpoint of our Xage Manager, whereby we're able to obtain the authorization request token and thus the bearer access token by supplying the login credentials for our user Mickey. Then, storing the authorization bearer access token with our script, we use that authorization bearer access token to call the data read API. Using the script, we're able to successfully read the data within our data store in the cloud. And we'll demonstrate that next. We start by initializing our read data API from device 1 Python script. We enter the login credentials for Mickey. And we see that we returned the most recent datum from that data source. Here we see just any random data from device 1 has been successfully returned. Next, we will attempt to write data from the second data source using our device2 write script. The script is the same as the device OneWrite script, with the only exception being that we attempt to write to the API as the second data source. As we can see when calling this API, we're not allowed to write to the API because we block the data write capability for data source 2 within the Xage manager, and we return a response code 403. We have an identical script to the read data API 1 script that attempts to read from the second data source, but because Mickey has not been provisioned access to read data from this data source, when we initiate the script, enter Mickey's credentials, we see that we return an error code with response code 401. This concludes our simple demonstration of the Xage Dynamic Data Security product. If you are interested in this product or have any questions, please contact us.